The relative contribution of those sensory systems varies as the relationship between the body and the external environment changes. So in neurotypical adults on a stable base of support, 70% of the information is coming from our proprioceptive and tactile receptors, 20% vestibular, 10% vision. But if we're on an uneven surface, there's increased reliance on vestibular and visual information. We see that in our patients all of the time, the visual fixation as a means to try and aid our postural control and balance. We have to remember that vestibular information is superior as it always refers to gravity. As sensorial feedback decreases, visual reliance increases. And light touch assists in the maintenance of verticality as well as increasing axial tone. So if we now go on to think about postural equilibrium, the coordination of our sensory motor strategies to stabilize the body's center of mass during both self-initiated and externally triggered disturbances in postural stability is the function of postural equilibrium. So our equilibrium is not a particular position, but it's a space determined by the size of the base of support, the limitations on our joint range, muscle strength, and sensory information available to detect the limits of that base of support. It's also important our neuromuscular coordination, our perception, and fear. When we talk about postural equilibrium, we're considering stability limits. That's our ability to maintain our center of mass within the limits of the base of support. And those are our stability limits. They're not fixed boundaries, but change according to the task, the environment, the individual, as well as practice.